It is Chapter 3, Programming with Calculus. In modern scientific computing, particularly for AI, calculus and linear algebra play crucial roles. In this chapter, you learn some selected topics in calculus that are essential for advanced computing tasks. We'll consider basic concepts and their applications as well. So you don't need to get any prior knowledge on calculus. Let's go to section 3.1, differentiation. The slope of the tangent line. A function y equals f of x can be graphed as a curve. In many applications, the tangent line plays a crucial role for the computation of approximate solutions. Here we have questions. What is the tangent line? And how can we find the n? Let's see this example along with the average speed and instantaneous speed. When f of t is time, f of t as a function of time measures the distance traveled at time t. The average speed is defined in this way. Average speed over t0 to t0 plus h, that is distance traveled over the elapsed time, and that is the quotient. Let's see here the meaning of this quotient through a graph. Okay, now in timeline, we have here t0, and h second later we have t0 plus h. Okay, then assume here y equal f of t is given in this way. Then this value is here, f at t0 plus h and f at t0. Then we try to get a secant line passing these 2 points. Okay, let's draw the secant line. Then, and again, we try to write down, draw the right triangle like that. Then this, the bottom length will be this one, t0 plus h minus t0, and this height must be same as this value minus that one, which is this numerator. So that this quotient is the slope of this secant line and average rate of change over this interval. So because here now f measures the distance, here the quotient is average speed over the interval. Okay? Now how about the instantaneous speed? For h very small, the instantaneous speed at t0 is approximated by this value. Here at t0, instantaneous speed is related with the slope of this curve. So that once you choose h very small, then this quotient will approximate the instantaneous speed quite well. Okay. Now we'll deal with this example along with a specific function. Okay, y denotes the distance fallen in feet after t seconds. Then Galileo's law of free fall is written in this way: y equals 16t squared feet, and t0 is 1, and we have to find the average speed. the difference quotient. Okay, let's try to find it. From H generally chosen, we have this one is, okay, F is defined in this way. So that rather than T, we are putting T0 plus H, so that there is a 16 T0 plus H and minus 16 T0 over that is H. Of course, here now, okay, I'm sorry, we have to put here square. And T0 is 1, so that by using that, we have here now, okay, the numerator is now 1 plus H squared, so that is a 16. 1 plus H squared is 1 plus 2H plus H squared, right? And then now minus 16 over H. Okay, so this is 16, that one will be canceled out, and then the numerator will become here 16 and 2H plus H squared divided by H. Okay, so that will be the same as, okay, H can be cancelled, and then there is 16 and 2 plus H. And we can rewrite this one 32 plus 16H, right? Okay, for H and various H, we can have the average speed in this way. Now, estimate the instantaneous speed at t equal t0. T0 is 1. Now, instantaneous speed can be obtained when h is very small. So we'll try to choose h small and smaller. H can be 10 to the minus 10, 10 to the minus 20, 10 to the minus 100, and so on. Then this value will approach to 32. So we can estimate the instantaneous speed here 32, because this term will approach 0, so that the middle term is 32. So we can say that the estimated instantaneous speed is 32. So that is the same as the slope at this point, right? Okay. Now, by using a MathTalent program, we can check it. Okay. This one is written for MathTalent, but if you want to use it in Octave, then you have to load a package. The grammar for loading a package in Octave is given in this way: pkg and load, and you have to load a symbolic, so that now you write in symbolic here. And that's it. And then this package will run, this program will run on Octave, okay? Okay, here, there's f of t, t0 is 1. Now here, and we try to get graph interval between now t0 minus 1.5 to t0 plus 1.1. This is for only graphic purpose. And this is the quotient difference. And then also, now we try to get the secant line for given h, and try to get secant line. That is now here the slope of the secant line, and this is line in point slope form. Okay. Okay, we made a plot here, and then we try to get now cube h, so the h is approaching 0. So this is a built-in function for the quotient as h approaches 0. you can have the limit. And we try to make, again, here tangent line along with red straight line. Okay. Now here this is a picture environment, and then here for each h, and here we try to print out the quotient, okay, and the difference quotient. Okay, that's the program. That is quotient, and h becomes smaller and smaller. Then it is approaching to here 32, and also that is from negative direction, and this is from positive direction, and it is approaching to 32. And this figure is also the blue dash lines are the secant lines, and now the red one is the tangent line. At 1, we can see the tangent line. So the slope of the tangent line is the instantaneous speed. Okay. And here, and we already did earlier. Now here, let's conform this algebraically. And f of t is 16 t squared, and t0 is 1. Then the difference quotient becomes in this way. Delta y over delta t is given here, so that after the simplifying, we reach 32 plus 16h. Once you choose h close to 0, then this value will approach to 32, so that the slope of the tangent line, the estimated the instantaneous speed is 32. Okay. Find on equation of the tangent line to the graph of y equal x squared at x is equal to. Okay. To find the tangent line, equation of tangent line, we have to know, okay, line can be decided with a point, and x0 is 2, so that x is 2. Then y must be 4, because the curve is y equal x squared. 2 squared is 4. Now, we need the slope. Okay, what is the slope? And here, measure the difference quotient and try to set h approach 0. Then we can find the slope, right? Okay, here. So function is x squared, and here, now the quotient is f, and x is 2, plus h, minus f at 2, okay, divided by h, right? Now f2 plus h is, okay, x squared, so that is 2 plus h squared, and once x is 2, the value is 4 divided by h, right? So therefore, from here we have 4 plus 4h and plus h squared, and we have minus 4 divided by h. Okay. Now we can cancel 4 minus 4 divided by h. We can reach it here now, 4 plus h. Once h becomes smaller, then this value will approach 4. So that must be the slope of this tangent line. Okay? Okay. So here we have the slope and the point. So point slope form of line can be obtained in this way. Y minus 4y0 equal slope, that is 4, and x minus x0, x minus 2. You can move this one to the other side. So that's the final answer. Okay. Here we define officially the slope of the curve for y equal f of x at the point P, x0, f of x0. A point is given, then the slope of curve is the number. Here, f of x0 plus h minus f of x0 over h. Now, we push h approach 0. So in this case, we write down this notation, limit h approaches 0. That means that after getting this quotient, we try to take h very small and becomes 0. And once the limit exists, then we use the number as the slope of the curve at the point. And we are using the notation here, f prime at x0 for that quantity. Once this limit exists, then we are using this notation. So the tangent line to the curve at P is formulated in this way, y minus fy0. In fact, that must be x0. I'm sorry, there is a typo. Okay, f at x0 equal f prime at x0 and x minus x0. This is the slope point or point slope form of the line, right? Okay, here, now can you find the tangent line to y equal x squared minus 1 absolute of this quantity at x0 equal 1? Once you try to make a graph of the function, then here originally x squared minus 1 is made in this way. Because of this absolute sign, the negative part is reflected to the other side. So that here minus 1 and 1, this curve has cursors. So here, once you try to get the slope, and then you have to check the limit. Now, limit, okay, here h approaches 0. That means that h can approach 0 from right side or from left hand side. So that h can be positive, h can be negative, so that eventually x0 plus h is right side of x0, and it can be left side of x0. So the limit must be obtained from both sides. So the existence of limit means that the limit from left side, limit from right side, both existed and they are the same. But here, for this function at 1, if you try to measure the limit from left-hand side, then the slope must be around this one. And if you measure from right side, the slope must be around this one, so that they are not the same. So here, we cannot define tangent line at the point. And in fact, this point is cursive, and the derivative, in fact, later on, it'll be called the derivative, and derivative doesn't exist. In other words, there's no tangent line we can draw, okay, at the point. Now, the figure is made from this program. Again, it is using symbolic packaging, and you can load symbolic packaging when you try to use Octave. Then it'll work, okay? Now, that's the end of part 1. We'll continue in the second part. Thank you.